Hi, I am Shakil Islam. I'm a PhD student in the Department of Chemistry and Biochemistry. I work with Dr. Armstrong. Today I'm going to talk about carbonate stars as green alternatives in chromatographic separations. We all know that HPLC is a fundamental tool to separate complex drug molecules. It uses different chromatographic methods like reverse phase, normal phase, mixed mode, which heavily relies on toxic solvents like acetonitrile and hexane. So here our study comes in to substitute these toxic solvents with more green solvents. We focused on carbonate esters such as DMC dimethyl carbonate, DEC diethyl carbonate and propylene carbonate PPC to show there are better or alternatives of these toxic solvents. From our study we able to show that we can substitute 50% of ACN with PPC and 30% of ACN with DMC, so it can make the analytical procedure more greener. Before dive into details, I want to give you some background on HPLC. HPLC consists of a solvent bottles. It has a pump inside. It has an injector which introduces the sample. It has a column that can separate complex drug molecules, and it has a detector that gives you response and results, and computer will give you beautiful chromatograms. Now I want to talk about the demand and toxicity of these solvents. Acetonitrile is highly liver toxin and it can damage kidneys, while hexane is neurotoxin. But both of the solvents are of high demands and this demands is growing annually. Now, as you can see from the table that these carbonate ester solvents are far cheaper and they have comparable physical properties with acetonitrile and hexane, so there can be a better alternatives of these toxic solvents. Then we did UV cutoff studies to show that these solvents will not interfere with the detection system. We found that the UV cutoff of these our solvents are close to 215 nanometer, so they can be a better alternatives in terms of chromatographic solvents. Then we did solvatochromic studies to show the polarity of these solvents, and we used Raker's dye, which is a Byton dye used to show the polarity of these solvents. When we put this dye in our solvents, it changes color and shows a chromatographic shift, from where we can use a calculation called ET30 scale. By using this scale we can find out the polarity of different solvents, and we found that the polarity of our carbonate esters are comparable with acetonitrile. Then we decided to go with mixed mode chromatography, as this mode uses a lot of acetonitrile. Before going into mixed mode chromatography, we did a stability study on this mode, and we found that the DMC and PPC is comparable with acetonitrile, but the DC is shifting with time. We did 20 hours of stability study. After stability study, we decided to separate 6 nucleosides and bases from a mixture. And we did concentration study just to show how much of PPC and DMC we can use to substitute this toxic acetonitrile. And we found that we can go up to 50% PPC, 30% DMC and 10% DC. As DC has poor solubility, we decided to go with DMC and PPC, and we found that they were able to separate 6 of them and providing uncompromising chromatographic performance. Then we used our method to separate functionalized nucleosides and its bases, and we showed that these two solvents able to separate 7 of these analytes successfully, and it's giving uncompromising chromatographic performance. Then we separated 3 vitamins with DMC, but PPC was able to separate only 1, and it's showing the last peak as a mix of analyte 2 and 3. Then we decided to make a method green method for normal phase. Uh, we did some study and we found that it's able to do some chiral separation in warfarin, and we showed that DMC was able to give comparable result with acin. Then we decided to use our method in polar organic liquid chromatography, which uses 60% of acetonitrile. Then we were able to substitute 60% of acetonitrile with 60% of DMC. That means we completely eliminate the use of acetonitrile. And we were able to show that we did some chiral separation of fluoxetine, and it's giving uncompromising result compared to ACN. Then we decided to establish a method in reverse phase chromatography to make the process more greener. Then from our study we found that we can substitute 20% of acetonitrile and 30% of acetonitrile with DMC and PPC respectively, and we able to separate 7 of these analytes in reverse phase, which are hard to separate even in traditional reverse phase chromatography. So to conclude, pharmaceutical industries and research labs use thousands of tons of toxic solvents to continue their daily operation. If we can even substitute 20% of ACN, we can reduce ACN usage by thousands of tons annually, helping making the analytical chemistry field more sustainable. These solvents harm human health and ecosystem, highlighting the urgent need for green alternatives. Our evaluations of solvent polarity, UV cutoff, stability, and chromatographic efficiency confirm their suitability for this application. In mixed mode chromatography, reverse phase liquid chromatography, and polar organic modes, we were successfully able to substitute 50%, 30%, and 60% of toxic acetonitrile respectively. And stability study confirms that these solvents are stable in chromatographic applications. Overall, our approach makes the chromatography cheaper, safer, and environmental friendly. Here are few references that I use for my work, and I would like to thank Dr. Wahab, Dr. Saba, and Siddharth for their help, and Egypt LLC and Robert Wells Foundation for their support and logistic supplies.